Look at Pythagoras' theorem. So Pythagoras' theorem we should know from last year. We talk about a right angled triangle. And Pythagoras' theorem says that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So the hypotenuse is the longest side of a triangle. To locate the hypotenuse, I always check there's a right angle by putting a line through it. It creates an arrow, which then points to a side. It's the longest side, it's the hypotenuse. Now rather than writing hypotenuse every time, I'm just going to label the hypotenuse as C. So I'm going to call C as my hypotenuse. And the other two sides I'll call A and B. So Pythagoras' theorem, the square on the hypotenuse, C squared, is equal to A squared plus B squared. And that's the formula that accompanies Pythagoras' theorem that we'll use in this unit.
I think of all the maths I learned at school, probably one of the most practical areas of maths I learned was Pythagoras' theorem. It's probably one of the areas I've used the most in my jobs around the house, I guess. So here, looking at this fence, you can see I've got a diagonal brace running down the fence to stop the fence from sagging. When I was doing this, I would have had to measure the length of that diagonal. Rather than measuring the length of the diagonal, I would have had to calculate the length of the diagonal. I would have done that by firstly measuring across here, from here across here, and then I would have measured down to here. And then using those two measurements, it would have helped me then using Pythagoras' theorem to find the length of that diagonal brace. So we'll do that now. But before we do, let's just say a quick good day. Hey Rocky, where are you? Rocky! Yeah, everyone say hello to Rocky. And you can see another diagonal brace over there on that little rough gate that I built.
Okay, so I measured my fence and I got these measurements. I got the length from here to the edge here was 1,120, and the length down here from the top rail to the bottom rail was 680, and I'm measuring in millimetres. So what I have now is I have a right angled triangle up here. And so then what I would have done next was, before I built this, so I would have calculated how long I had to cut this. So I would have used Pythagoras' theorem. So with Pythagoras' theorem we know that C squared equals A squared plus B squared. And we've learnt that previously. C is the hypotenuse. So the hypotenuse is always opposite the right angle. So I'll draw a line through here, points to C over here. That'll be the hypotenuse. A and B will be the other two sides. So first line working out, write the formula. Next line of working out, expect to see the same in your books. Substitute in these values. Now at this point you reach for your calculator and do the calculation. So C squared is equal to 1,120 squared plus 680 squared, that should say. And so you should get an answer of 1,716,800 is C squared. Now the last step in the Pythagoras' theorem is always take the square root of your answer. So you can just do that in your calculator, take the square root of that number, and we'll come up with C is 1,310. So the length of my brace on the gate would have to be 1,310 millimetres long. Another area that I've used Pythagoras around the house is not just to make a right angle, but also to check if something's a right angle. So when I was building our pool fence, so it needs a bit of a paint, but anyway, when I was building our fence, I had to make sure that the two edges of the fencing met at a right angle. And so I would have done that by doing something like this. I would have gone here and I would have measured a set length. Now I'm going to measure along here now, and I'm going to measure along here 600. So just going to, give me 1 second, I've got to mark that. Okay, there's my mark for 600. So it's 600 away from this bit of fencing over here. I would have measured then from this bit of fencing a mark of 800. Sorry, this bit of fencing. I would have measured from this bit of fencing along here a mark of 800. So now I have two marks. I have one at 600 on this bit of fencing, I have one at 800 over in that bit of fencing. Then what I want to do is I want to check this diagonal along here to see whether or not along here makes a right angled triangle. So whether or not it fits Pythagoras' theorem. So I can measure that now quickly. 1 second. Unfortunately, I find it's hard to do on my own, but I have actually measured this to be exactly 1,000. So 600, 800, 1,000 is the length of the hypotenuse. Then then I have to go through and I have to run through my Pythagoras' theorem and check to see whether or not that actually fits Pythagoras' theorem, those three numbers. Of course, being a bit of a smart and clever person, I know about Pythagorean triads, and I know 6, 8, 10 is a Pythagorean triad, which would make a right angle triangle every time. So 600, 800 and 1000 must also make a right angle triangle every time. So I can proudly say that in the corner of my pool fence here, this is a nice right angled triangle. Okay, so just going back over that for the pool fence, I measured 600 from one corner, 800 from the other corner, put a mark. I had to check along here, and I came to this measurement here along here as 1000. And the question was, does this match Pythagoras' theorem? Is this a right angle? Was actually what my question was. Is this a right angle? To check that, I was going to see whether or not it matched Pythagoras' theorem. So I was going to use c squared equals a squared plus b squared, taking this is what I'm hoping will be a right angle. If it is, line through it, points to the hypotenuse, this would be my C. So I've got, does 1000 squared equal 600 squared plus 800 squared? So on this side here, 1000 squared would be 1 million. And that would be my left hand side. And my right hand side will be 600 squared will be 360,000 plus, and 800 squared would be 640,000, which adds up to nicely 1 million. So therefore c squared equals a squared plus b squared, so therefore it's a right angle. Okay. But as I said in the video, I already knew that because of this, what I called a triad. Now, Pythagorean triads are three numbers that we know fit Pythagoras' theorem. So probably the most famous Pythagorean triad is 3, 4, 5. We know that works in Pythagoras' theorem every time. 5 squared, 25, 16 plus 9. Any multiple of that will also work. So the multiple I was using, I was doubling it, and I was going 6, 8, 10 must also be a Pythagorean triangle. 10 squared is 100, 8 squared is 8 squared is 64, 6 squared is 36. 36 plus 64 equals 100. So any multiple of that, even if you multiply them by 100, will give you Pythagoras' theorem. Okay, one other thing to look at is using Pythagoras' theorem not just to find the length of the hypotenuse, but also to find the length of what we call a shorter side, one of the other two sides. So in this example, we want to find the value of x. I'm going to start off exactly the same way. I'm going to draw a line through there, points to the hypotenuse, I'll label it as C. My other two sides I'm going to call A and B, and it really doesn't matter which order. I'm going to start off the same. I'm going to write c squared equals a squared plus b squared. I'm going to do exactly what I did last time. I'm going to substitute the 17, 15 squared plus x squared. I'm going to think back to my equation solving unit and think, well, if I want to get x on its own, I have to subtract 15 squared from both sides. So in other words, I get 17 squared minus 15 squared is equal to x squared. Now I've got x on its own, I just need to solve it. I'll do the calculation over here and plug that in the calculator. I get 64 is equal to x squared. 64 equals x squared, then x will equal the square root of 64, means that x is equal to 8. So that's it. Find the length of the shorter side with Pythagoras' theorem. X is 8. Now you're not always going to get nice whole numbers, but every time you do get nice whole numbers, you've formed another Pythagorean triad. So in other words, the whole numbers 8, 15 and 17 form a nice Pythagorean triad. And so you know any multiple of them will also form a Pythagorean triad. So if you double it, 16, 30 and 34. In other words, these three numbers will be the sides on a right-angled triangle. Okay, I just want to finish with a couple of examples. This one, find the side length of this square correct to two decimal places. And so because it's a square, we know it's going to have a right angle on the side, so we have a right-angled triangle here. So Pythagoras' theorem must work in this. So this length here is x, which means the length over here must also be x. That's a little bit unusual because we've got two sides we don't know, but we do know the third side. However, Pythagoras says there must be a relationship between these three sides. So there's my right angle, that must be my hypotenuse. I'll write down my Pythagoras' theorem. And I'll fill in the blanks. Hypotenuse C is 5. 5 squared must equal, A and B are both the same, they're both x squareds. So completing this, I get 25 is equal to 2x squared. Now, I'm pretty much there. I just have to solve a simple equation that we've solved before. I'll divide both sides by 2. I'm going to rewrite it on this side. X squared is equal to 12.5. And then the final step is going to have to take the square root. So x will equal the square root of 12.5. I can throw that in my calculator. I'll get my answer, 3.54 when you round it off. So the length of the side of the square is 3.54 centimetres in this case. Okay. Another one which involves Pythagoras, find the area of this trapezium. So I've got a trapezium here and I need to find the area of it. Now, you might recall the area formula for a trapezium is h over 2a plus b. And a and b are the parallel sides, so this is a and this is b. But h is this perpendicular height. And I don't have the perpendicular height as yet. So what I need to do is to calculate that. And I can see that over here, by putting my h over here, I form a right angle triangle. The length of this side must be the difference between these two. 16 take away 12 is 4, so that'll be 4 metres. And then again, my right angle triangle points this towards my hypotenuse. So I can go ahead now and calculate h. I can say c squared is equal to a squared plus b squared. I can sub in what I know. So 6 for c, 4 squared, plus the other one's going to be h squared. To calculate h, it's a shorter side calculation. I have to solve the equation. So I'm going to subtract 4 squared from both sides. So I get 6 squared minus 4 squared is equal to h squared. I'll just reverse the order. I'll put the h squared over here. 36 take away 16 is 20. H will equal the square root of 20, which when we round it off, h will equal 4.47. So I've done my Pythagoras' theorem. It's given me the height of the trapezium. I can now come back to the area formula, put my height in. I'll add my parallel sides in. I'll take care to make sure I've stored this whole number, not the rounded number, but the complete number in my calculator. I'll go through and I'll calculate that out, 62.61 metres squared for the area. So a couple of ways you may be asked to use Pythagoras' theorem. When you are confronted with a triangle, it's a right angle, it's one of the go-to methods as to how you may find a missing side.